Good evening everyone and welcome to the live class in our channel Diksha Karnataka. This is again live for our A series of maths class. Okay, so before I begin, let me check if I'm audible and visible or not. Yes, so checking guys. Okay, all good, no problem right there. Okay, so good evening first of all and welcome to the class. Today I'm here to discuss your theory part, the concept part of the chapter, inverse trigonometric function. Alongside these concepts, I have also brought some questions that will help us understand these concepts better. Okay, so let's look at the first. So of course, it has certain parts to be included over here. Inverse of trigonometric function. It means whatever we have learned in trigonometric functions, for example, sine function, cos function, all of these, we try to find inverse of them. Okay, sir, yes, we have learned in chapter number 1 that what is the inverse of a function. Inverse of a function means, what is the meaning of inverse of a function? So inverse of function means that for any bijective function, that's the flow. If the function given to us is bijective, so for any given function, if it is proven to be bijective, then we can try to do what? We try to find a function g. Okay, we try to, let's say the function f is defined in this fashion, set a to b, then we try to find the function g which is defined such that the domain and range are swapped, and of course what happens over here, the GOF becomes IA and the FOG becomes IB. Means if you put any value in the GOF, okay, the result is always identity function on the set A, and FOG will be a result in identity function of set B. Okay, so this is, I hope the definition of inverse function is clear. Okay, now inverse of trigonometry, it means whatever trigonometric functions we have, sin x, cos x, tan x, whatever it is, we'll try to invert them, we'll try to prove them it is bijective, and once we do that, we find their inverse form, which is sine inverse, cos inverse, tan inverse. But one thing is very clear, that we have to prove it is bijective. We have to prove it is bijective. That's the most important part, and our energy in this class will be going on that. So because most of you guys don't understand this, this basic thing clearly, and that's where you make mistakes. Okay, so we'll try to prove bijective. Now if I draw this function for you, okay, what is the understanding? Sin x, cos x, tan x, any of these functions are not bijective. How can you say that, sir? Let's try to take this example, y equal to sin x, y equal to sin x. If I take this function's graph, let's find and draw the graph of this function. This is the graph, if you remember. This is the graph of sin x. All of you will agree with this. This is the graph of sin x, sir. And if I draw a straight line parallel to x-axis, I'm getting infinite number of intersections, because this graph will stretch to both the sides. So I'm getting infinite number of intersections. So if you look at this graph right now, what is my domain, guys? My domain is all real number, and my range is very clear and easy, -1 to 1. Domain is all real number and range is -1 to 1. But the given function is clearly what? Many one. It is a many one. If it is many one, means this function over here is not bijective. Not bijective. And we know that very well, for any function which is not bijective cannot be invertible. Cannot be invertible. So this is the understanding, this is the situation that we have. But we know very well that inverse actually exists, right? We know very well that inverse actually exists. Means something should be done over here to make it invertible. To make it invertible. And what will that be? So there comes a concept which is called as restriction of domain. Something which is called as restriction of domain. So we have to make the function invertible, and that is called as, there's a concept which is called as, okay, limitation or restriction domain. When we apply this concept, there are some conditions that you have to follow through, and if you are able to do that, you will be able to restrict the domain and you'll make the given function y equal to sin x invertible. Let's try. So what is the restriction? What's the limitation? That if I draw the function y equal to sin x only for this, notice this value, only in the domain of minus pi by 2 to pi by 2, only in the domain of minus pi by 2 to pi by 2. So if I'm writing, let's say, a function fx equals to sin x, where domain of the function is what? Simply minus pi by 2 to pi by 2. What I've done, I have given a restriction, I have cut the domain like this. Then you might ask me a question, sir, can we cut the domain as per our choice? There is a condition. What is the condition? Range should remain same. The condition over here is very important, and that is range is always kept unchanged. Check here. If the domain is this minus pi by 2 to pi by 2, the respective value of the sin x will be what? Minus 1 over here and 1. So the range of the function will not change, and that will remain as minus 1 to 1. So whether you go and take the previous example, which is over here, domain is all real and range is minus 1 to 1, or this case if you check, domain is all real, domain is minus pi by 2 to pi by 2 and range is minus 1 to 1, range is kept same. So the only condition that is required to create restriction or limitation on the domain is range is always kept unchanged or same. Now if you do that, look at the function now, it will be example of 1 1 and onto function. This will be always 1 1 and onto function. So anywhere you draw the graph, the function will be always 1 1 and onto. This is a 1 1 plus onto, and you know this is called as bijective, and of course in terms invertible. Acha, don't worry, for sin x part, no, I'll go in more detail, because if you build this, the concept of invertible, how do you find it, all of that, if you build properly, others we don't have to spend so much of time in it. So for sin x function, we'll spend more time to understand how it is working. So I hope this is clear. Yeah, let's move on then. Inverse of a function, I have explained it already. So this definition is explained. How do we write it? So we write trigonometric function as y equal to sin x, and this will become what? Y equal to sin inverse of x. Domain was what over here? Domain was, now we have changed the domain, minus pi by 2 to pi by 2, and what is the range now? Minus 1 to 1. So when we talk about sin inverse, this works ulta. Domain becomes minus 1 to 1 and range becomes actually minus pi by 2 to pi by 2. As we know already, in the case of inverse of function, in case of inverse, domain and range interchanges each other. So d over here is the range actually, and d over here is the range in the case of sin inverse. Okay, this is how it works. Just with an example I'm explaining you over here. Okay, so this is clear, sir, but it is only invertible if what? It is taken in the domain of minus pi by 2 to pi by 2. So far so good. Next, so next part is about understanding how this actually is invertible and how does it works. So far I have gone to this graph. I've gone to this graph. Excuse me. Let me draw it again. Very important to see this. So far we have this particular graph, right? This particular graph we have. So this is sin x, and if you remember, I taught you this. How can we actually find the inverse of any function? By taking mirror image, across the line which is y equal to x. This is the line. Does not look straight, but this is the line, y equal to x, and this is the function sin x. How do you take mirror image? Very simple, sir. Let's have a look. So image of this side will simply come like this. This and this are mirror images, and for this side you'll have the image like, excuse me, okay, for this side you'll have the image like this. So the yellow part is sin x, and this graph is nothing but graph of sin inverse of x. Sin inverse of x. Okay, so if you look at the graph of sin inverse of x, it works around finally like this. This is the graph. Okay. Okay. Will there be arrow over here? Will there be arrow over here? Tell me. Will there be arrow over here? Anybody? Hi Sharath. Tell me whether will there be arrow over here? Do we have arrow over here? Answer yes or no. We don't have arrow over there. Why is that? Because this value is limiting at 1. It is not moving forward. We have kept it at pi by 2 should be equal to 1. So this arrow that you have seen there should not be there. This arrow cannot be there actually. So the actual graph is only like this. Okay, and how will this look like on the x and y axis? This x axis and y axis. This value is going to be, excuse me, yeah, minus pi by 2. Okay, sorry, the output, no, minus 1, right? This is minus 1 and this value is 1, and this right here is minus pi by 2 and is over here pi by 2. So output of any inverse trigonometric function is always an angle. So when we go about y axis, you'll have angle over here. Across x you'll have your domain, which is going to be the values. So minus 1 to 1 is your domain. This is the value. And if you look at the nature of this function, nature of this function is what? Minus, sorry, this is not clear. Nature of the function is what? Actually increasing in nature. So you can write, one of the highlight over here is that it is increasing function. It is a increasing function. How can you say that? If you move from left to right in x-axis, the y value is increasing. Okay, if I take, let's say, a point over here and a point over here, for this point this is my y value, for this point this is my y value, right? So this y value is more than this y value, right? This is the respective y value over here, this is the respective y value over here. So clearly for the second point, which is towards the right side, y value is more. Okay, this is a increasing function. I hope this is clear. Yeah, good. Let's move on. So this is how it means. And for all of you who are sincerely preparing for KCET, check out our full year batch for KCET, which is Pariksha Veera. The classes already have begun from 6th of July. The fee of this course is 3499. What we are providing over here in this session, in this particular batch, is full PU to syllabus coverage alongside KCET preparation as well, and that each subject gets 110 plus hours of live classes. That is done for physics, chemistry, maths and biology as well. Okay, so you have 110 plus hours of each. Actually, you have 20 plus tests available for part and full length. You have teachers notes, you have assignments, unlimited DPP generator, all provided as the part of this particular course. And you can access this course on the Vedantu app. Okay, simply download the app from the Play Store, and to get to know more details about this particular course, simply check the description given in this particular, link given in the particular description of this live. Okay, so please check this out. If you want to, don't make any delay, get it done as soon as possible, so that you won't have too many backlogs. We have only finished first one and few parts of second chapter, so get it done as soon as possible, and then you'll have less backlogs and continue the live classes. And all the previously conducted sessions from 6th July to today will be given to you as recorded ones. Okay, domain and range of ITF, this we have already cleared. It simply swaps, it simply interchanges, right? Okay, this is the word to mention over here. The restricted domain, if you use that, it becomes simply the domain becomes range and the range becomes domain. Okay, clear. Okay, whenever no branch, this is very, very important. There's something called as principal value branch. So when we define this value as minus pi by 2 to pi by 2, no? After we define this to be a restricted domain, this is what becomes principal value branch. Check here. This restricted domain of the trigonometric function becomes the range or principal value branch. Okay, and if nothing is mentioned, if no branch of inverse ITF is mentioned, we have to assume it to be always principal value branch only. Don't worry, I'll give you a list of all of them. Okay. So graph of ITF, I've already done this part. Sine inverse, I have done this proof. It is increasing in nature. It is an odd function. What it means to be odd function? It means sine inverse of minus x is always minus sine inverse of x. How can we say that? Because odd functions are those functions which is, if you want to know what is odd function, symmetric about origin. So about this origin, this you can see this part and this part is symmetric. Okay, means they are reflected about the origin. Okay, that's the odd function. What is the maximum value? The maximum value of this will be 1 and minimum value of this will be, sorry, maximum value of sine inverse, right, will be pi by 2. This will be what? Minus pi by 2. So clear? Okay, that's the sine inverse part. Let's move on to cos inverse. How do you get this part, the cos inverse graph? Let me draw it for you for cos inverse. So you'll go like this. First you have to draw the cos graph. What is the cos x graph looks like? If you remember, generally without the restriction of domain, it looks like this, sir. Right? That's how it looks like. Again, if you try going from here, you'll have in not bijective, so we cannot create an invertible function of this. But if you make changes, what is the change going to be? If you define the domain as 0 to pi, why will I do that, sir? Because I need to keep range always same, which is minus 1 to 1. Now if I do that, the function is changed. 0 to pi, how will the graph look like? Starts from here actually and goes all the way till here, right? Yes, sir. So this is your value 0 and this is the value pi. Now, how will I take it and find the cos inverse? Same way, just draw this line, y equal to x. This is the y equal to x line. This is the cos x. You take the mirror image about this. So this will be the graph, actual graph. This and this part is mirror image and this part is the mirror image of this. Can you check? This part over here is mirror image of this thing, basically like an arrow. So it goes something like this. If I have to show you, 1 second, this is like this. This is one of the part, the mirror image about this line, and the other one is like this, the mirror image. Okay, so my final graph of cos inverse of x, which is y equal to cos inverse of x, goes like this. Check here, starts from this and over here. This is the graph. This is the point 0, of course origin, and input over here will be what? This will be minus 1 to 1, sir, and this will be 0 to pi. This is again, there is not arrow over here. This is the y equal to cos inverse graph. Domain and range are clear. Please check. So what is the domain and range? Domain of this graph will be always minus 1 to 1, and range or principal value branch will be what? Will be 0 to pi. Is it a odd function, even function? Not possible, because you check, for even function it should be symmetric about y-axis, which is not there, and for odd function symmetric about the origin, which is not there. So neither odd nor even. Maximum value is pi, minimum value is 0. And what about the function? It is decreasing in nature. This is a decreasing function. How come, sir? If I move about x-axis from left to right, the function drops. See, the function value of y is keep coming down. So cos inverse. So I hope there's no doubt about this. Okay, great. So this is the cos inverse part. So sine inverse, cos inverse, both are dealt with. Okay, moving on with tan inverse, of course. How do you do tan inverse, sir? So first three I'm going to explain you how to do it. For tan x graph, if you remember, y equal to tan x graph is very unique graph. it goes like this. You have over here, then you have again over here, and this value is, sir, of course, this is 0, this is going to be pi, this value is pi by 2, this is going to be 3 pi by 2, because at odd multiples of pi by 2, what happens? The graph becomes undefined, right? Tan becomes undefined. Again, we have to make sure range remains same and restrict the domain. Range remains same and restrict the domain. So what we do, we can just choose this part. We can choose just this part. And when I'm doing that, have a look. So let me just, so right now what is my domain, guys? Just to show you, domain right now is all real number except for odd multiples. So odd number is 2n plus 1. Odd multiples of what? Pi by 2. That's my domain. From all real numbers, remove the odd. Odd means 2 into n is even number, plus 1 will be odd number. 2 into any natural number is what? Even number. Achha, n belongs to over here integers, by the way. Will be odd integer, right? If I take any n integer, 2 into n, 2 into anything will be even, plus 1. Next number will be odd. So odd multiples of pi by 2, you have to remove from the all real numbers. What about range, sir? Range is always this, minus infinity to plus infinity. See, this goes all the way down and up. This arrow over here, it keeps going left and right, both sides. Let's look at the restriction now. So how do you restrict it? So when you restrict, this function becomes y equal to tan x, and domain we keep what? Minus pi by 2 to pi by 2. Open or close? Open. Why open? Because at pi by 2 it becomes infinity. Infinity we cannot define it, so we can't close it. Okay, so open and open. What about range? So of course range will not change, minus 2 plus infinity. Let's draw the graph of the functions. Okay, let's look at this. This is my tan function, sorry. This is the tan function. Okay, and this right here is that line y equal to x, and if I take mirror image of this, it will come something like that. If I take mirror image of this, it will come something like this. This is my function tan x. This is tan inverse of x. Tan inverse of x. So if you draw tan inverse of x, you'll have only this value. I gave the boundaries right over here, yeah, minus 1 to 1 and 0 to pi, correct. If I draw this part, yeah, so just if I have to draw the final answer, it will look like this. You'll have results like this, and backwards over here, this goes all the way till minus infinity, this is plus infinity, and this upper bound is what? This lower bound is minus pi by 2, and upper bound is plus pi by 2. This is which graph? Y equal to tan inverse of x. Tan inverse of x. Please check. Upper bound is pi by 2, lower bound is minus pi by 2. Domain is all real number. Domain is all real. Range is what? All real means minus 2 plus infinity. Range is what? Minus pi by 2 to plus pi by 2. And one more thing, increasing function. This also is a increasing function. One point is this, and second point is, of course, you can see clearly also an odd function, because clearly symmetric about origin. You see that over here? This part over here is reflected and this part. Okay, so they are symmetric about origin, correct? Hence it is odd function. So what it means? It means tan inverse of minus x is equals to minus tan inverse of x. Okay, clear? So far, any doubt? If you have any doubt, bacha, please put that in the comment section. Okay, no doubts. Moving on. Okay, sir. Next is what? Cot inverse. Cot inverse. So I've done the proof of first three, how to draw it. Similarly, you can apply the result in cot inverse also. So domain will be what over here? Check. domain of this function will be again all real from minus to plus infinity. What about range? It will be what? 0 to pi. Range will be 0 to pi, but since it is infinity, we'll be having open intervals, and this is a decreasing function. Decreasing function. What about odd even? Not possible. For odd, it should be symmetric about first and third, and for even, it should be symmetric about first and second. So means it should be like this actually, but it's not the case. So not even, not odd. Cosec inverse, this is again a decreasing function. Okay, so if I have to write here, the domain over here, the graph is written. Domain if I have to write, what is the domain? So minus infinity to all the way minus 1. Minus 1 also, it is defined union 1 to infinity. This is my domain. I can go all the way till minus 1 and again 1 to infinity. What about range, guys? Same way, for range also we'll have minus infinity, range will be having minus pi by 2, not infinity, sorry. Minus pi by 2 to pi by 2, right? And from this, basically remove the value 0. From here to here, but 0 you have to remove, correct? What about this? This is a decreasing function. You can see this is a decreasing function, because if I move towards this side, the y value is going down. Here also, if I move from here to here, y value is going down, so decreasing. What about odd function? It is odd function. How come it is odd function, sir? Because you can see this point, if I take, it's over here. It's symmetric about the origin. So odd function, it means cosec inverse of minus x is what? Minus cosec inverse of x. Right? This is clear. Got it? Please check one more time. I've given all the information. Yes. Second verse, look at the graph, because graph can help you in a lot of ways, okay? You get to understand questions better, you get to understand calculus better, so understand the graphs. Yeah, first three are more commonly used. The last three, which is sec inverse, cosec inverse and cot inverse, are not that many times we have used, but first three are very, very useful. Second verse now. What is domain, guys? Check your domain. So minus infinity to minus 1, same thing. Minus infinity to minus 1, this has same result, sorry. This is open, this is closed, union 1 to infinity. Range is what? Range is different. 0 to pi except for pi by 2. 0 to pi except for pi by 2. Pi by 2 can't be there, because at that point cos is 0, so sec will be undefined, right? Hence sec inverse does not exist. Okay, what about the function? It is increasing in nature. Check. It is an increasing function. How come, sir? If I go from left to right, this way, y increases. Here also, if I go from left to right, y increases. So increasing function. What about odd even? We can't say, because for it to be symmetric in this, it has to be in this fashion, which is not there, right? It should be like this. It should be symmetric in y-axis. That's first and second quadrant. So that's not there. So it's not symmetric in this. So not even, and odd means it should be over here. Okay. Next. So this is a summary of all the domain and range. Okay. Cosine inverse, cosec inverse. So summary, this has to be very, very important. Acha, there's another name for range, by the way. This is called as principal value branch. And this is the principal value. Sometimes they'll use that in the questions, whether it is board or it is CET, they'll use that. So you have to be ready for that. Okay. Because this operation also, no, sine inverse of sine x. This is true when x is between minus pi by 2 to pi by 2. This is called as principal value branch. This is the PVB. Getting it? Getting it? So sine inverse of sine x is x, correct? This is equal to x, correct? But when x lies from here to here. Okay, so all 6 are important. Graph of only first 3 is important. Sorry, graph of sine Tan and cos inverse is important, but domain and range for all of them are important. Okay, so please have a look. Now this is summary of all the graphs at one place for your reference. Download the notes, you'll get the access. Okay, yes. Dr. K is asking, DRK is asking, sir, can you give the most important PYQ of this chapter in one video, maths along with the theory? So yes, I think you are not then following, it started, right? So yes, we'll give you PYQs and theory in one video also. This is, we are doing over here in live because you get to ask a doubt, okay, in the recorded sessions that we can give, or in the other classes, if I'm giving you a video of that, what will happen over there? So to make it more interactive, we are taking this live as well, and will help you in the one shots also. So don't worry, every Wednesday my sessions are coming over there, and that will be having everything in it, okay? But here also we are learning with the proper, basically with the interaction, with the questions, with the concepts at the same time, okay? So just simply I'm telling you one thing, this is for DRK, follow the channel and get the access to AIO page. It is all in one page, okay? Link, let me check whether it is available in this. 1 second. Yeah, okay, so all right, this is not there, but in the one shot lectures, no, you'll find the AIO page link available. So you go and join that, and over there you can check the schedule and all the past classes. And so if you do that and if you follow the channel, you'll get to understand this in that how the structure is going on, how you're learning the classes. And of course, if you want more help, of course we can share, we can come up with a class and tell you how we are working in terms of academic sessions and how it is planned, okay? But for now, you can simply subscribe to the channel and be, basically I'm telling you, be a part of WhatsApp channel. If you're there, all the classes are shared over here, and yes, we'll be providing you a session in which, to answer your question, I will provide you a session in which you'll have everything. Don't worry about that. Let's solve this question first. The principal solution of cot inverse of -1 by root 3. So if you are here, if you can answer me this question, would be better. Please try. Yeah. Cot inverse of -1 by root 3 will be what? We just solved right now. This is not odd, not even. This is a property which goes like this. For pi minus cot inverse of 1 by root 3. So pi minus, this is going to be what? This is going to be cot inverse of 1 by root 3 is how much? Pi by 3, right? Because when tan is root 3, cot is 1 by root 3. So it will become pi by 3. So that is going to be 2 pi by 3. Answer is option A. Everybody got that? Previous one? Answer is option A. Correct, DRK. But to answer your question, yes, we'll be providing you everything. Just join. I hope you're already part of the channel, WhatsApp channel. But if not, please join the WhatsApp channel. You'll get every update over there. And I can understand your issue. We'll try to come up with a session where we'll give you the entire schedule in what days, what classes are coming. Okay. Next, the domain of function cos inverse of 2x minus 1. How do you solve it? Domain. So domain of cos inverse is what? -1 to 1, sir. So instead of x, we have over here 2x minus 1. So solve it. Bring -1 over here. -1 over here, it becomes -1 plus 1, 2x, 1 plus 1, right? This becomes 0. This becomes what? 2x only. That's 2. Now divide 2 on both the sides. It will be what? 0 by 2, x and 1. So my answer is 0 to 1. 0 to 1. What are your answers, guys? Let me see. Yes, A is the right answer. Very good. Thank you for giving your participation. Cos of tan inverse of 3 by 4. Very difficult question. Of course not, sir. This is theta. So what are they asking us basically? Cos theta is what? Why this is theta, sir? Because tan inverse of any value will be an angle. So let's do one thing. If I take tan inverse of 3 by 4 as theta, it means what? It means 3 by 4 is tan theta. 3 by 4 is tan theta. And if you draw the right angle triangle over here with this value to be theta, this is 3, this is 4, and this is 5. 3, 4 and 5. Okay, all right, 3, 4 and 5. So if I want what? I want the value of cos theta. I can apply cos theta is not nothing but my adjacent by hypotenuse, so 4 by 5. What's your answer for this question? So your answer is again 4 by 5, which is option A. Correct. Super. Good job. Next. Domain of fx sin inverse of x plus tan inverse of x plus sec inverse of x. So whenever you have function f plus g plus h like that, okay, and you try to find their domain, basically what you have to do, domain of f intersection g intersection, so d of f, d of g, and d of h. D of h. What is d of f, sir? What is domain of f sin inverse function? -1 to 1. -1 to 1. What is domain of the function g, sir? All real numbers. Function h, sir? -∞ to -1. Open here, closed here, union 1 to infinity. So what it means? I'll show you. Draw a number line and check. My first one is saying -1 to 1. This is the domain, sir. Both closed. Other one is saying all, sir, actually all real number. And another one is saying this closed, sir, and over here all the numbers. 3 are there. If you take intersection, we have only one value each side. So we have one of this value over here, one of the value over here. It means this will be x equals to -1, x equals to 1. When we have only two values like this, how do you write it? You write it like this: x equals to -1, comma 1, -1, comma 1. That's your option number B actually. I think you did not see, that's why you answered it wrong, right, DRK? Because we want elemental value, and elemental value comes from the middle bracket, not the square brackets or smaller brackets. Yes, B is correct. Okay, moving on. So we are done here. 1 second. Here. Now let's just revise some properties over here. So as I mentioned, sin inverse of sin x is equal to x when the x is in the principal value branch. And this is true for all the 6 trigonometric functions. Cos inverse of cos x, tan inverse of tan x, cot inverse of cot x. All this is true only when in the case of principal value branch. Clear? Okay, so we have to remember this. Very, very useful. Alongside there, this domain, the range, that also you know. Now, this already explained to you. This is because it is odd function. This is odd. This is also odd. And this is also, where is it? This is also odd. For the case of odd function, it is always simply minus sin inverse of x, minus tan inverse of x, minus cosec inverse of x. But over here, you will have another pi added. You'll have pi added. Okay. So this is basically a list of your some formulas, reciprocal and complementary identities. So this is also there. Sin inverse of 1 by x is cosec inverse of 1 by x. How do you prove it, sir? How do you prove this cosec sin inverse of 1 by x is cosec inverse of 1 by x? Let me show you. Sin inverse of 1 by x is cosec inverse of x. How can we prove it? Let's try from here. If I take sin inverse of 1 by x as theta, I can take what? 1 by x, and sin inverse on this side will become sin theta. So I can write here x equals to 1 by sin theta, and how much is that? Cosec theta. So we have x equals to cosec theta. Take this over here back, you get cosec inverse of x is theta. You have taken this value as theta. So this theta is nothing but cosec inverse of x now. That's what we have to prove. Check. That's what we had to prove. Clear? Is this clear? Yes. So in ITF, one questions sometime like usually two questions comes, but last year we had only one direct question, but most of the time two questions come from ITF, but it does have many questions in or many application in calculus. What is odd function? So odd function here, DRK, are the function which is symmetric about origin. So this is your function, let's say over here. Okay, so if you look at your sine inverse function, this is it. This is sine inverse. This is the graph of sine inverse function, right? Can you see? This is symmetric about origin. So whatever functions are symmetric about origin are called as what? Odd functions. Because if you look at this point, you'll have mirror image over here. If you take x as minus x, it'll simply become over here. I'll show you. What is sine inverse of 1? Sir, pi by 2. Right? This is where? Somewhere this side. Okay? Now look at sine inverse of minus 1. What is this value? Minus pi by 2. So basically, if f of minus x is equals to minus fx, this is the definition of odd function. So in this sine inverse of x, you put x as 1, you're getting pi by 2. But when you put x as minus x, which is minus 1, you're getting minus pi by 2. So when f of minus x is minus fx, it becomes odd function. Clear? Hi Bunny, how are you? Yes Bunny, I remember you. Of course I remember you. Yes. How are you doing, Bunny? All good? Preparation? No, odd function definition will not change. This is the definition of odd function, right? Please check. It's just how you're using it. Odd function definition is always same. This is what you have in integration, right? It is not different. So which college you are going for, Bunny? It's been so long time. Yes. Bunny is your senior, your senior from the previous year batch. Okay, and this is also someone very common formula, sine inverse of x plus cos inverse of x equal to pi by 2, very commonly used in CET. Okay, this is the reason. So this value is pi by 2 because of the complementary pairs. Sine x and cos x is complementary pair. If you want, I can prove this part also for you. Sine inverse of x plus cos inverse of x is pi by 2. Let me do that. Let me prove this for you. Sine inverse of x plus cos inverse of x is pi by 2. Is pi by 2. How can you do that, sir? How can you do that, sir? DRK, is it clear for you? How it is odd function? You did not reply. Is it clear for you? Yes. So if I do it like this, no, check, minus cos inverse of x, apply sine over here, check, sine over here, I get what? Pi by 2 minus cos inverse of x. What happens to this side? Please check. This becomes simply sine 90 minus theta. This is some angle, right? It becomes what? Cos of theta. So cos inverse of x, that's becoming x, right? And if you had sine inverse over here, you move on this side. Okay, you move sine on this side, it simply becomes what? X equals to x, which is true, right? It is true, no? DRK, all good, right? Let's move on then. Okay, so this was the important results that I wanted to show you all. Please check. Clear? Yes. Moving on. Sum and difference of tan inverse. Tan inverse of x plus tan inverse of y. Tan inverse of x plus y upon. So this is like this. Tan inverse of x plus y upon 1 minus xy. Okay. Over here, this is the case when xy is less than 1. Written here. It is less than 1. What happens when xy is more than 1? X into y is more than 1. Then it becomes pi plus same value. Okay. All right, this is tan inverse of x plus tan inverse of y, same condition. Okay, and this is the condition for tan inverse of x minus tan inverse of y. So conditions are given over here and the formulas are given over here. Here the most important ones is this one and this one. These three are most important, and sometimes this also is asked. This rarely asked, very rare. But these first and last is the most priority. This also sometimes has been asked. Okay, right, moving on. Double angle and triple angle identities. Now this, if you remember, difficult too because of the presence of those many numbers over here. So if you remember double angle formulas of what do you call trigonometric function, that is also sufficient over here. But if you remember this, the answer can be much quicker. You will have much faster approach in CET. 2 tan inverse of x in terms of tan will be 2x upon 1 minus x square. I'll repeat again. 2 tan inverse of x in terms of tan, because I can write this formula in terms of sine inverse and cos inverse also. In tan inverse it is 2x upon 1 minus x square. In sine inverse it is 2x upon 1 plus x square. And in cos inverse it is 1 plus x square in the denominator, and this will be 1 minus x square because of the ratio, of course. So in terms of tan, 2x upon 1 minus x square. Sine inverse 2x upon 1 plus x square, and this will be 1 minus x square upon 1 plus x square. So tan inverse in terms of tan inverse in terms of cos inverse and sine inverse. Okay, this is sine inverse formula. How do we get this? Same formula, sine 2 theta formula, 2 sine theta cos theta, and this is cos 2 theta formula. Okay, triple angle, less used but it is still important. I've given you a list of all the formulas over here. Yeah, these three are very, very important. These three are very, very important. Even this two also, but this is more asked, less asked. Okay, conversions also amongst the ratio itself, means if they might give you sine inverse of x and directly we have to use this to solve the question. We do that very often. Okay, we do that very, very often in the questions, especially in the PYQs of CET. You will find that. Okay, sine inverse to cos inverse, tan inverse, cos inverse, sine inverse, tan inverse. If you want to solve it, simply draw a right angle triangle. Take any one case. Let's say I will take this as theta. So take this over here as theta. This is right angle triangle. Let's say if it is given as x, means this is x and this is 1. This will become what? 1 minus x square. Writing this. This by this will be over here. X by this will be tan. This by this will be cot. So 1 minus x square upon x will be cot. Okay, not given here. Okay. Clear, guys. All right. So basically I've given you formulas at one place. Once you have the notes, you can simply revise all the formulas, remember all the formulas. Notes you'll all get in the WhatsApp channel, so join that. Sec square of tan inverse of 2 cosec square of cot inverse of 3 is equal to what? Very simple question. Also PYQ, by the way. This is the KCET PYQ. Sec square is nothing but 1 plus tan square. So 1 plus tan square. Everybody in the live, please tell me the answer for this question. Tan square of tan inverse of 2 plus 1 plus cot square of cot inverse of 3. 1 plus tan of tan inverse becomes what? Simply 2, and they have a square, so right here a square. Cot of cot inverse will come simply 3, and there's a square, so write square. So why you are able to do this? Because square is on the cot, so I can write this as simply cot of cot inverse of 3, and then take the whole square, right? So this becomes 3, and your square is simply going to be this value. So 1 plus 4 plus 1 plus 9, 10 plus 5, so 15 is the answer. D. Let's say how many of you got it right. Okay. Yeah, cool. Next. Now guys, this is your last question for the day, so please solve this before I end the class. Give me the answer, I'll wait for your answer, and then I will solve it. I'll give you 1 minute. Please try. Pencil value of sine inverse of cos sine inverse of minus root 3 by 2. This is the board level question. Which option is right? Tell me. I'm waiting for your answer. Anyone? Any answer? Start from where? Here. Sine inverse of minus root 3 by 2. This is going to be the formula of sine inverse of minus x, which is nothing but minus sine inverse of x, odd function. So this goes like this, minus sine inverse of root 3 by 2. This becomes minus pi by 3, right? This is nothing but minus pi by 3. Once we have that, we'll get to this cos. Check here. So cos of minus pi by 3. Cos of minus pi by 3 is positive only because it is the fourth quadrant, and fourth quadrant cos is positive. This will be what? 1 by 2. So I have this. Now we'll apply the outside value one more time. So sine inverse of 1 by 2, right? So this I did in the first phase, first part, second part, and third part. Sine inverse of 1 by 2 is how much? Pi by 6. So answer is option B. Answer is option B. So this was the session where we discussed important formulas, the graphs involved. So if you look at overall, chapter altogether, not much is there except for the formulas and the graphs of the function. But the problem type is very important. So in the next class, when I come up with the part 2 live of this particular chapter ITF, okay, in that class, which will be on Friday, next Friday actually, every Friday and Saturday we'll have a class. Okay, so next Friday when I'm coming live, I'll discuss those questions again. Okay, so make sure that you have this notes by then. How will you do that? Simply join the WhatsApp channel, and over there we share the notes. You get the notes over there, and once you have the notes, review all the formulas and be ready with the question solving class. Okay, and of course for more sessions you have to join the AIO page. We have said already with all of you. It's a beautiful platform designed to help you to make it more personalized for all of you. Okay, and all the information regarding that was given in my yesterday's session, which was said in, of course, as one shot class of relation and function. So please go and check that video out if you want. If anyone has anybody needs clarity regarding this, all in one platform that we have created for all of you, and this is something which is completely free. We are not taking a single rupee for this platform. So basically, to make learning more personalized, to make learning chaos free, any noise free. What happens when you study on YouTube? Sometimes you are watching something else, getting distracted, or you have few more options to go through, and because of that what happens is you lose interest very soon, right? But to make you learn in a classroom environment, what we have done, we have created this platform for you. It's all in one platform. Okay, and it's completely free. All right, how to access it? So simply go and watch my relations and functions one shot video. In that we have shown you all the demonstration required to access it. Now if somebody is not able to do that also, no problem. Simply do one thing. In this video's comment section, you tell me that you have a requirement, you are not able to access the AIO platform, then we will share that link with you in the comment section only, and you're going to be able to use it right away. Again, understand this, it's completely free, guys. Okay, paper. So we'll do one thing. You just put this in the comment section, not in the live chat. Put your query in the comment section, not in the live chat. I will share your because Jasmine ma'am isn't working on this side. She will be able to give you better information regarding that. So I will share your question with Jasmine ma'am, and she will be able to take it up and answer your doubt. Okay, so I'll do that. Okay, I'll do this for you, and but you have to put this same question in the comment section, not in the live chat, because after the live is over, we will not be able to reply to the live, right? So make sure that you are putting in the comment section. Okay, so anything else? Acha guys, I hope this is clear. All of you are clear about the platform that we are giving you to learn better, to learn in a proper classroom environment, even at home, even for free. Okay, so next level of personalized attention. So try to join that platform, try to make use of it. We have created it just for the sake of your advantage. We are not gaining anything out of it, just for your advantage, for making sure that all of you who are sincere, who are actually looking to study properly, should get an opportunity to do so. This is the platform. If you have any doubt regarding this, just put that in the comment section, not in the live chat, in the comment section, and we'll give you the link and we'll give you more details about it. Okay, that's all in this class. I'll see you in the next one. Okay, anything else? No. Yes, so that's all in this class, and I'll see you in the next live. Again, as I'm gonna tell you one more thing. Every day, every math live class will be on Friday and Saturday, so be there for the classes. But again, don't worry about any of these things. Simply join the WhatsApp channel. Over there we share the upcoming schedule of the classes. Okay, that's all. Now with that, I'm gonna end the session today. I had fun teaching you all, and I hope you found this session helpful. If you did, let me know in the comment section and give me a like for this particular class. That's all. See you in the next time, in the next class. Take care. Bye bye.